that's working now. Again, if there's any problems with the audio, do let me know. And then as well as anything else, using a little bit of a different setup tonight. So if you have any issues, please type them into the box. Okay, looks like we are live on YouTube. Okay, great. All right, so it looks like there might be a little bit of a delay, but anyway, we'll get started. And okay, thanks, Brenda. I'm glad the audio is good. So essentially, we are tonight going to talk about looking at nutrition through a different lens. Over the many weeks that we've been together, I've spent a fair amount of time talking to you about how to look at things from a different lens, looking at it from the lens of, say, heart health or skin health, or the lens of metabolism, looking at it from a mitochondrial perspective or fat loss perspective, looking at the overall idea of health through these different lenses. And I was walking through the Miami Public Library near me, and I saw this book on the new books shelf. As you can see, it's still from the library. It's I do plan on buying this book because I always think you should reward authors who wrote great books, and especially new books. And this book called Eat Like the Animals, What Nature Teaches Us About the Science of Healthy Eating, which was written by David Raubenheimer and Stephen Simpson, gave me a view of human health through the lens of an animal biologist, someone who's done work with insects and someone who's had a clear idea of how nutrition and eating apply to animals. Now, it's one of those things that you can study these sorts of ideas in animals, but it's actually very difficult to study them when it comes to humans. And the reason is for a whole host of reasons. One is, humans have a long lifespan. It's easier to do studies on, say, dogs. There's a lot of currently dog longevity studies that are being done because you can be alive during multiple dog lifetimes, which is unfortunate because we love our dogs and we wish they would live a lot longer. The truth is that they live a shorter life, and we're able to do certain studies on those on dogs. Nothing terrible, just looking at longevity and nutrition and a whole host of things. And of course, you can do all kinds of studies on all different kinds of animals. Now, that doesn't mean necessarily that those particular studies are perfectly translatable to understanding humans. Of course, they aren't, but there are certain rules and laws that tend to occur that can be generalized from animals all the way up to humans. And some of those concepts are what we're going to be discussing tonight. And this is the reason I really like this book, is because it goes through just what I spoke of, but it's written so well. It's written like an adventure. And for anyone who is curious about how real science takes place and the thoughts of researchers, getting into their minds, I really highly recommend this book because it gives you an idea of how science is done, and how science is thought of. And I really enjoyed the book. So let's get into some of the concepts of the book. Again, looking at human nutrition and health through the lens of what nature and the science of healthy eating, what can we learn from these animal studies? So let me share my screen and we will get started. Okay, here we go. And let me blow up my screen and hopefully you can see me all right. All right, so again, we're talking a little bit about some of these concepts. Now, well, first we'll talk about problems with human studies in nutrition, of which some we've spoken about. 2, dividing up appetite. We think of appetite as just this thing that is, we're hungry. And, we even can understand that sometimes we are hungry for certain things. Maybe we're hungry for meat, or hungry for starch, or hungry for salt. We'll talk about these different types of appetites and how they're looked at in science in the animal world. Then we'll talk a little bit about what's called the protein leverage hypothesis, which basically states, as a summary before we get to it, that most animals prioritize protein over everything else and what that actually means. And then we'll get into why not eat more protein if there is this thing where animals are really trying to leverage protein more than anything else. Why not eat more protein? And we'll look at the positives and negatives of having too little or too much protein. Then we'll talk a little bit about food environments and really what's happened to humans in terms of what's happening in their food environment. Believe it or not, if we are living in a situation where all the food is natural and we've had a historic concept or historical connection with these foods, believe it or not, humans end up eating a very specific ratio of protein and can customize just from our palates, just from our selections, from almost in a subconscious way, the perfect diet for us. But as humans have gone through all these different changes in history, that has changed significantly in such a way that it's difficult for us to rely on our inner sensitivity because we're eating foods that we're not used to eating historically. And then we'll talk about how we've already established, just as an introduction, that protein is prioritized. And you'll understand what that means and understand that in different parts of our life, we have different protein targets. And these protein targets are really interesting and also give us a different perspective on human health in general. So let's start off, and then we'll end tonight's class. So let's start off with a concept that will help you understand this particular thing. First of all, because we're going to be talking a lot about protein tonight and the implications of this, we should all understand that all natural foods have protein, have carbs, and have fat, or vegetables all have those things. Now, protein doesn't necessarily have any carbs. It does have a tiny bit of carbs, but so in generally speaking, most natural foods have protein, fat, and carbs. Now, if we look at the breakdown per calorie, meat is somewhere around 20 to 25% protein per calorie, that is. Of course, there's other things in meat like fat. And it can range from 12 to 35%. 12, like duck as an example. Rabbits are even lower, like 8%. Vegetables, 15% to 50% per calorie, believe it or not. Spinach is close to 49% protein. Now, the implication of that is, of course, we're talking about per calorie, which means you would have to eat to get the same amount of protein in meat, even though it potentially on a per calorie basis has higher protein. You would have to eat. You wouldn't even be able to eat that much. 1 cup of spinach might be 50%. Might be 50% protein, but it also is only like, probably 12 calories or something of that sort. Whereas you're dealing with meat, you're having a whole lot more calories and you're getting a whole lot more protein. But as a percentage, it actually has more protein. The spinach, that is. Fruit is under 10% usually. Beans are in the mid-20s. Potato and yams and sweet potatoes are 8% protein, a little bit less. And so we're going to be talking about this sort of magic number of 15% carbohydrate, 15% protein. And I just want you to all be aware before we jump into that these are what we're dealing with when we think about natural foods. And we'll come back to this, but that's an important concept for you to understand before we get into things. Now, let's talk about the problems with human studies in nutrition. We've spoken about one already, the long life. It's very difficult to do longevity studies because it's very difficult to control populations and look for longevity differences. You're not actually there's obviously ethical issues about taking an entire population and doing a study on them. So we can only do observational studies looking at history when we're talking about, say, longevity. But if we're trying to do a study where we're basically looking at variations of protein to carbohydrates to fat, these sorts of things, it's hard to lock people up in a situation and use these as dials, because you can do many different things to someone's health by dialing up different carbs versus protein versus fat. These are difficult studies to do. Additionally, when we look back at what people ate, there are whole sorts of biases that come up where people record things differently. They might record according to what they think the study researchers are looking for. There's all kinds of regulatory issues dealing with what you're going to feed people, whole host of problems with human studies. So when it comes to that, then we can look at what the science has to say when we look at it from the lens of someone who's doing animal research, insects and animals and such. And what they've discovered is that we have multiple appetites. And we'll get into what those 5 primary appetites are. But in this book, they basically discussed that they started looking at locusts, and they wanted to see basically what of the primary appetites, those being, listing them now, protein, carbohydrates, sodium, calcium, and fat. And these are capable of causing you to have an appetite. Now it is sometimes in animals and in humans even somewhat subconscious. You're not necessarily conscious of what you might be desiring or having an appetite for. But what they found, and they were starting to look at locusts, is that they prioritize protein, which means that if they were in a natural environment with food that was low in protein, they would eat more of it in order to get a certain amount of protein. And the same thing happened if they were in a high protein environment. They would eat actually less to get to a certain amount of protein. And they looked at it they studied all these insects and animals. They looked at it from these various different appetites. Yes, these other appetites existed for sodium, if you were salt restricted or carbs, but the one particular appetite that was the most important, the strongest appetite, was to try to get the amount of protein in the diet correct, above and beyond everything else, which basically meant, and this is what the protein leverage hypothesis is that we'll get into, which basically meant that animals and people, will learn in just a moment, prioritize getting a certain amount of protein, which means that if they are eating, say, processed foods, as an example, and I'm sort of jumping ahead only because I think it'll make some intuitive sense to you, that if people are eating processed foods that are incredibly low, abnormally low in protein, then they're going to continue to eat more and more because this protein, even though there might be, just a tiny bit, they're going to continue to eat more and more, just like these locusts did, in order to get a certain amount of protein in their diet, meaning that this appetite for protein was stronger than everything else. It overcome everything else. And therefore, people ate more to get to that level of protein, with the notion, of course, that we discussed before, that all foods, essentially natural foods, have some protein in it. So if they were eating very, very low, they're going to eat more. We're talking about animals as well here. But ultimately, they realized that there are 5 separate primary appetites. Protein is the strongest. And then, of course, we have, as I said, carbohydrates. You can have if you are in a situation where you need, if you're on a low carb, super low carb diet, you're going to crave carbohydrates. If you are on a low sodium, super low sodium diet, you're going to crave salty food. Same with calcium, and same with fat. And therefore, we have these primary appetites. The key here, again, established in the book, and in many insects as well as animals, there were a few rare exceptions. Protein was prioritized above and beyond everything else. And these appetites are appetites in the sense that they get us to start eating, but also to stop. In other words, once you've reached the level of protein that you need in, assuming you are in this completely natural environment. We're going to understand in just a moment that once we've changed the food environment and introduced all these crazy new foods that are devoid of any nutrition, that really throws a wrench into the system, and is one of the reasons why we have this obesity crisis that we have now. But ultimately, these appetites that we have for protein, carbs, sodium, calcium, and fat also tell us when to stop. But there's a delay. I mean, we all know, and I've said many times, it can take 15 to 25 minutes for you to realize you're full, but there is a delay, as I said, and this delay we need to be conscious of, especially if we're eating processed foods that don't have the natural feedback mechanism. And what's that? It's fiber. If you're eating an incredibly high amount of plant matter, then the fiber is going to act as a feedback mechanism sooner than later. Therefore, it's always a problem when people are adding foods, things like oil, a lot of oils to their diet, because you're not getting any real feedback mechanism. But if you're eating that same amount and you're getting a whole host of fiber, that's going to create, as a fair amount of bulk, which is going to, activate the stretch receptors in your stomach and tell you that you're full. In addition, the fiber is going to feed your microbiome. And we know that a fiber-rich diet mixed with soluble and insoluble plant fiber is really going to optimize, the beneficial bacteria in your gut. And that, going back to several lectures we've had in the past, is so important to your overall health. And I'm not going to go into that much because we're trying to look at this from the perspective of these biologists. But as you know, it acts as a brake on overeating, and it feeds this microbiome so that you are overall healthier. Okay, so now we understand that, one, it's very difficult to do human studies on nutrition, and therefore maybe we should look at what the animal studies show. And we've already established that there is this prioritized idea about protein, but that there are 5 separate appetites, but the protein is really the strongest, which leads us to this, what's known as what they describe as the protein leverage hypothesis, which basically means that that there is humans, as well as the locusts that they mentioned that they went through the studies in the book, prioritize eating a target amount of protein, which means that in a protein poor environment that we actually have, which is where people are eating processed foods, where sugar, processed carbohydrates, and oils are making up the majority of people's diets, humans are going to overeat carbs, in this case, and fat to reach a protein target. And that target, believe it or not, comes out in humans. If you look at populations around the globe, the average really comes out to around 15% of calories that are contributing to people's diets in an ideal setting. Now, they've done these studies where they take people and they put them in a situation. As an example, they'll take people into like a resort or a spa where they feed them a certain amount of food, and they'll take people and they'll put them in all the foods that they have available to them for the week are low protein, lower than 15%, let's say. And what will happen is they'll end up eating more of those foods, so much so that some of the studies show that they started to gain weight at the end of the week to get to, they didn't even know they were doing it. But they were overeating to get to what would be, 15% protein for the amount of calories that they should be eating. But because they're overeating to get the enough protein, they end up eating too many carbs and too much fat. The same thing happened on the other side. They gave people protein levels higher than 15% in a whole wide selection of foods. And as we know now, intuitively, right, if they had too much protein, they would end up reducing the amount of calories because they've already sort of hit their thermostat level of protein, so to speak, and they would stop. And therefore, they were able to, some of these folks ended up losing a little bit of weight. Now, we know that people go on high protein diets do tend to lose protein. And we'll talk about why not just eat more protein in just a moment. But I should talk about the final study they did, which was basically where they sort of had selections where people could, they could choose. And believe it or not, they ended up eating around 15% of their calories from protein when they had certain choices, a variety of choices. So humans have this sort of innate ability in a completely natural environment to end up eating around 15% of our calories from protein. I think that's an incredibly fascinating conclusion and something that really turns things upside down a little bit when we have all these debates about, what the macronutrient levels of your food are supposed to be. Now, I'm not saying that this is our ideal, and this is going to lead to perfect health if you just choose 15% of your calories from protein. It's just an observation, but one that is still, I think, really enlightening when we think about all the debates that we're having about protein. So that really leads us to the next thought. Well, if we're dealing with this situation of people having, an incredible amount of obesity, and we realize that if they overeat protein, they're also going to undereat calories, might that be a way to correct the epidemic? Well, it definitely would lead to weight loss, but at what consequence? And unfortunately, in animals, there is a reproductive benefit when you eat more protein. In other words, when they look at animals, and really, if you look back at sort of hunter-gatherer lifestyle where they were eating more protein, they would basically reproduce and die around 40. And in insects as well as animals, when you increase protein, there actually is a reproductive benefit. They produce more eggs, they're more fertile, and there is a reproductive benefit, but there's also a decrease in longevity. Lower protein, in general, going on the other end of the spectrum, was associated with a longer life across species and also probably humans when you look at the studies. Again, the issue here is that there are certain cultures around the world that have lower than 15%. One example is Okinawa, where I think it's like 9 or 10% of the calories are from protein. And there is obviously, again, I'm not saying this is the only reason that they live a long time in Okinawa, but there are observations that a lower protein was associated with a longer life also in that case in humans. But there's other things going on, and there's all kinds of biological pathways that are activated when you are basically going lower on protein. There are we've spoken about them before when we spoke about things, certain nutrient signaling pathways that are activated when you're eating a lot of animal protein. And these are basically associated with sort of a situation that can lead to lower longevity, but also are associated with, more muscle, believe it or not. So again, it leads back to this idea that when they did the studies in mice in particular, they were able to breed these mice that they looked fabulous. They were like lean and, they were reproductively really well, but they died early. And it makes me wonder, people who are eating an enormous amount of protein and, they're big muscle men. They look good. The question is, are they activating, or I should say, they're not activating these longevity pathways? Now, there are many people who say that if you combine a moderate amount of protein, higher than 15%, that is, with, things like intermittent fasting and fasting mimicking diet, you might be able to eliminate these risks. And I think there's probably something to that. Again, we're not going into that tonight because we're looking at it from the perspective of the authors of this book. But ultimately speaking, generally, higher levels of protein in and of themselves are generally not associated or are basically associated with decreased longevity. So that's the reason. And also too much protein generally can be toxic. So, but that has to be incredibly high. And they had some anecdotes in the book about that. Okay, so moving right along to this understanding food environment. So now we've established several things. We've established that it's difficult to do human studies. We've established that there is this protein leverage hypothesis and that we have these different appetites, but protein is at the very, very top in a sort of a ideal setting. And we've discussed sort of some of the pros and cons in terms of research where they analyzed levels of protein in the diet. Now we understand that animals, if you put them in a natural environment and they have a whole host of choices in front of them, they are going to eat a completely nutritionally balanced diet, almost in such an uncanny way. Like they're able to completely eat exactly the same amount, same ratios, basically, of macronutrients that they need. They know how to select. They're just in tune with what they need. Orangutans basically will get just the right amount of protein. Now, in this case, if fruits are abundant, they'll eat them to store fat to get them through periods when they're low on fruit. Speaking about all this, basically, the point being is that in nature, animals have this amazing capability of choosing the right foods for themselves. But unfortunately, we are not living in the wild with a whole host of choices. We have lots of choices. The problem, the choices we have are not necessarily the best for us. And humans have gone through several stages in human history. There was the introduction of fire, which basically changed the way we ate. We were able to eat, heat up tubers under the ground and make those starches more available. Then we went from hunter-gatherer to agriculture, where again, we made this shift and started eating more starches. Then we went to industrialization of food production. And this basically spread all these unhealthy foods throughout the planet, where traditional places unfortunately, places like Okinawa that had this amazing healthy diet with a long, healthy life, now, unfortunately, through the industrialization and the export of all the crazy American fast food that we've created, are displacing traditional foods throughout the globe. So it's not the first time this has happened. Again, introduction of fire, hunter-gatherer to agriculture, industrialization of food production. It's just another step in really distancing ourselves as a species, I guess, from our natural environment. And when we get to that particular place, unfortunately, it's not going to allow us to adapt fast enough to be able to have that intuitive sense of what we need to eat, especially now when we have all kinds of crazy things like processed carbohydrates and natural, unnatural, quote, natural flavors and all kinds of things that, change the sensitivity of our palate to certain foods. We get an abnormal sense for sweetness, an abnormal sense for salt, all these appetites, that we spoke about, like the salt appetite, gets changed when you're eating lots and lots of artificially salty foods. And it also probably messes up our ability to, I know it does, it unfortunately causes us, when we're eating all kinds of hyper sweetened foods, unfortunately that changes our ability to perceive the natural sweetness of fruits, as an example. And therefore, maybe if we have a desire for carbohydrate in the form of fruit, we might not get it right in a natural sense because our palates have been damaged by all the natural foods that we have. So here we have the spread of natural foods. And so unfortunately, humans they're completely unadapted to this situation of having these ultra processed foods that, going back to what we were speaking about before, are typically low in protein, low in fiber, they have unhealthy carbs, and they have added flavor enhancers. And all of these, I guess, is ultimately leading to a situation where we are not able to naturally select the foods that are going to be good for us because we've been completely unable to adapt. Certain primates and such in the wild didn't have to go through the introduction of fire or a hunter-gatherer phase or dealing with the industrialization of food. They're able to choose what they've been eating for some time, and therefore they don't have an issue with obesity. They'll eat in certain periods of time, like we spoke about. They'll eat more fruit to put on some fat for when their period's low on fruit. They're able to learn how to balance these things so in the natural rhythm of their life. But for us, dealing with all these new types of foods, it's really, really near impossible. The conclusion, of course, is that we should make sure that we're eating as unprocessed as possible, so that we can start to regain some sort of inherent sensitivity to the foods that we're eating and not be completely having our palate just completely destroyed by all these new foods. But it gets even worse than that. And we'll speak about that a little bit now. Now, we spoke about this concept that humans, if given the choice in a natural setting, will end up eating around 15% protein. But during lifetime, there are different moving protein targets. Now, babies, believe it or not, human milk is 7% protein. A lot of people are surprised at that. And it's 38% fat and 55% carbs. So therefore, babies in general only need 7 or 8% protein. Now, mothers and babies, they've found some interesting things. Now, when a mother is eating around 16% protein, which is on the lower side for a mother, a pregnant woman, the babies will have higher amounts of abdominal fat. Not a good thing. If they eat 18 to 20% of fat in protein, they get a good chubby baby in the right ways, the chubby arms and chubby cheeks like we all like to see in our babies. And that's good. If they're eating a lot of protein, the babies end up being too lean in an unhealthy way. So mothers and babies have a different protein target. Now, when you get into middle age, again, it's sort of that 10 to 15% range. And then at 65% and 65 and up, you actually need more protein. And we've, of course, spoken about the work of a doctor by the name of Dr. Walter Longo, who came up with the fasting mimicking diet, biological fasting, who has, really shown that you do need to be careful with animal protein specifically, because those animal protein activates these nutrient sensing pathways. They can lead to decrease in longevity, factors that are associated with longevity. Again, there are people who say that if you incorporate fasting, then that might and probably will allow you to be able to enjoy some of these animal proteins without the negatives. But that's for another episode. So 65 and up, you actually need more protein. The reason is basically your body is not capable of absorbing and it loses more protein than it should. And so when you're getting older, you need to increase your protein level. Now, remember what we spoke about when it comes to eating natural foods, and all these natural foods, if you're eating a lot of them and you're not diluting your diet with incredibly low fiber, low protein foods like, lots of starches and lots of fruit, then you're eating vegetables and some, a little bit of animal protein or whatever the case may be, you're going to get, you're going to get there. So we have this moving protein target, but again, the key here is that there is a very specific, target when it comes to protein. Finally, we're going to talk a little bit about really what's happening in this spiral of obesity. And we've spoken a lot about insulin in the past. And insulin, of course, is released when you're eating, say, a high sugar, starchy diet or food. And it allows basically the cells to be open so that they can absorb the sugar into the cell. But insulin also blocks the breakdown of muscle. Now, why would it do that? It's intuitive if you think about it. If you are in if you're in a state where basically you are not eating, I mean, essentially you want it to if you're breaking down muscle, it means that your body is using the muscle for energy, essentially. If you're eating and your insulin level goes up, your body is clearly getting food and therefore it doesn't need to break down muscle. And that's why insulin blocks the breakdown of muscle. It's an indicator that your body says, okay, we're feeding now, I don't need to break down muscle. Unfortunately, when we get into this situation where people are overeating and they're getting into a state of pre-diabetes and type 2 diabetes, where people are getting insulin resistance, we've all heard that, then unfortunately the muscle doesn't listen to the message anymore. And it continues to release protein into the bloodstream, which means you're losing protein, which means that the protein target is going to go up. And you know what happens when your protein target goes up? You end up overeating to try to get to that level. So unfortunately, we have this very, very unfortunate spiral, again, looking at it from a very narrow lens, that leads us to this situation where, unfortunately, you end up getting the early stages of insulin resistance, which makes your body say, I need more protein, which then makes you want to continue to eat more, and this never-ending cycle. There are other cycles that are going on here. We've spoken about them before when it comes to diabetes and insulin resistance. But this is one that is very unfortunate. So that is really what I found really interesting about this book. And we can go through this in a brief summary that can summarize things. By the way, interesting is that something I didn't discuss that just sort of popped into my mind is that, different animals have different targets, of course. And it's interesting to be able to see how certain animals evolved. As an example of the dog, dogs evolved around humans. And so when you look at the protein target between a wolf and a dog, they're actually quite different. They don't need as much protein as a wolf because they have evolved and adapted to living with humans, living from the scraps of the table, and have gained the ability to handle starches and a whole variety of foods that fell from the tables of their human owners. So animals have had the capability of evolving over the years. We unfortunately have introduced things so rapidly, we haven't had the ability to evolve. Now, certainly there has been some evolution. As an example, when we moved from hunter-gatherer to agriculture, then we developed these amylase genes that allowed us to be able to digest these new starches that we started to introduce into our diets. But with the massive industrialization of food, we haven't really been able to adapt. And that is basically throwing everything off. So to summarize what we went over tonight in very, very briefly, we have learned that when looking at animal studies, there are those 5 appetites that we have: appetite for protein, appetite for carbs, fat, sodium, and calcium. And We all instinctively know that we have these. If we craving salt, it means we probably haven't had enough salt. Of course, unfortunately, that has also been disturbed by the amount of salt hiding in foods and leading us to overeat that sodium in a lot of cases. And we've learned that in animals and in humans, there is a preference for eating, not a preference for eating protein, but for getting a certain amount of protein. And if we don't get that, we end up overeating. If we get it too much, we end up reducing calories. But just by eating more protein isn't really the answer. We discussed some of the negatives of eating too much protein, but we've also discussed how potentially things like fasting can moderate some of that. Then we spoke about food environments and how over and over again, these in nature, animals are capable of really choosing what they need to choose, but unfortunately our environment has changed too rapidly, so that if we end up eating processed foods that are lower than that protein limit, we end up massively overeating foods. And therefore, unfortunately, that contributes to this obesity problem. On top of that, by eating all these, we end up getting insulin resistance, and that insulin resistance causes this spiral where we feel like we need even more protein. This sort of set point, which changes throughout life. In this case, abnormally gets set too high, which leads us to eat even more food. So, what's the end result here? The end result is it is interesting to look at what's your caloric value, the amount of using a tool like Chronometer, which I recommend for people to take a look at things in their diet. And you can look at what, say, 15% would be of protein generally, see what that is, and then look at how things play out with the food that you're eating. Anyway, that goes beyond a whole host, that goes beyond this particular talk. But that's basically what I wanted to go over. I really found the book interesting. Again, I didn't cover everything in the book, but let me stop sharing my screen. I obviously didn't cover everything in the book, but I recommend it. It's a very, very good book, and I hope you found it as interesting as I did. At least some of the conclusions I found were incredibly interesting, and the story of the book is really fascinating. So hope you enjoyed that. Next week, I'm going to be discussing vitamin D and immunity to viruses. And the reason we're doing that is because there have been some interesting studies revolving around vitamin D, in specific in regards to the worldwide situation that we find ourselves in, and when it comes to a specific virus. And I was speaking to a friend of mine who just refuses to take any sort of supplements. And as I've always said, you really need to have a reason for taking a supplement, because, there's no supplement for everyone. But I'd like to choose vitamin D and look at its role in immunity with a special reference to viruses in general, as well as the virus that we're dealing with in this worldwide situation that we're in. And I think what you'll find is data is pretty convincing in regards to vitamin D levels. I'd also like to go over how vitamin D by itself has some confusion to it, and that there are certain things like magnesium and vitamin K that need to be taken with vitamin D, and you'll understand why that is. It actually makes complete sense when you understand the biology, and it makes you wonder why you would ever do a study just expecting vitamin D by itself to have, to increase lifespan or decrease overall mortality in general. Supplements can be very good for very specific, narrow things, and that's what you should choose them for. And anyway, we'll be discussing all of that next week, and I really do think you'll find it interesting, especially given the situation we're in. So hope you enjoyed that. Appreciate your attention. This was episode 80, and I look forward to seeing you next week for episode 81, next Wednesday night. I'll see you then.